All right, so if when you do the row reduced echelon form for this larger matrix, like we did in here on page 3, if you do that and you get a row of zeros, then the original matrix does not have an inverse. So if you do that, you'll just say that the matrix does not exist. So not every square matrix has an inverse. All right, so finally, let's see how to solve systems of equations by solving matrix equations. Okay, so recall if we have a system of equations, so this is a 3 by 3. If you write the matrix of coefficients, so this is coefficient 1, 1, negative 2, negative 4. If you put that in a matrix, this is the coefficient matrix from last time. And then this is the unknown column, x, y, and z. So we're trying to solve for x, y, and z. All right, so how can we do that? So I have that A, the coefficient matrix, times the x equals b. So I'm trying to solve for x. So this A right here is bothering me. I would like to just have x equals something, because then I solved for x. So I can't divide by I can't divide by a matrix. So I need to think about what can I do to get rid of this A, this matrix A? Well, I can multiply by the inverse. Because if I multiply by the inverse on both sides, right, if I do something to one side, I have to do it to the other side, then what is A inverse times A? Well, we know that that's the identity matrix X. So then, but then what is the identity matrix times anything? Well, we know that is just that matrix X, right? The identity matrix times X does not change X. It's like multiplying by 1. So then there we have the answer. The answer, the matrix composed of X, Y, and Z, is just going to be the inverse matrix times B, which is this. So now, what is A inverse for this one? Well, we just calculated. So to find A inverse, this is the same matrix as the one we have on page 3. So you do this process to find A inverse, and we got that A inverse was negative 3, negative 4, and 1, and then 2, 1, 0, 0, 2/3, and 1/3. So then to solve this system of linear equations, the x vector, which is the x and y and the z, is going to be A inverse times the b. In A inverse, we found that is negative 2, negative 3, negative 4, 1, 2, 1, 0, 0, 2/3, 1/3, times the b vector, that's just the constant term, 7, 5, and 0. So this is a legitimate matrix multiplication because this is a 3 by 3 and this is a 3 by 1. So the result is going to be a 3 by 1. So it's going to be negative 3. So I'm going to have just 3 entries. 1, 2, 3. A 3 by 1. 3 rows, 1 column. So negative 3 times 7, that's negative 21 plus 10. And then plus 0. So negative 21 plus 10. And then negative 4 times 7, negative 28 plus 5 plus 0. Negative 28 plus 5. And then 1 times 7 is 7 plus 0 plus 0. So it's going to be negative 21 plus 10, negative 11, negative 23, and then a 7. So we solve the system. This is the value for x, y, and z. X is negative 11, y is negative 23, and then z is 7. So this is how we solve a system of equations using inverses. First of all, you write the system in matrix equation form. So you put in the coefficient matrix times your unknown matrix times your constant matrix. Then you find the inverse of your coefficient matrix and you follow the steps listed on this page. You find the row reduced echelon form of this matrix. So basically you perform row operations until you get the identity matrix on the left hand side, and then what you have left on the right hand side, that's your inverse. Then to get the answer, you simply multiply the inverse matrix by the B matrix, and that gives you the solution. Okay, so this is it for section 10.5. You will practice more in the homework, and lots of the questions in the homework have videos as well. So if you need more practice, definitely watch the videos and do the homeworks. And then in section 10.6, we're going to learn yet a couple more methods to solve systems of linear equations using determinants.